So somehow I gave myself the job of trying to convince you at 9 a.m. that dirt is really important. And in particular that sand, a more specific word for a type of dirt, is a vital resource. And how is it that something as tiny as a grain of sand can be considered this vital natural resource? Well, part of the reason is that sand stabilizes and protects the beaches that we care about. And those beaches have a tourism and recreation value. Sand is also used in concrete, so it's part of a multi-billion-dollar construction industry. And then sand often contains minerals, precious elements that are important and often lead to controversial mining operations of sand. And so let's go to one place where rivers meet the coast and deposit a lot of sand. This is the Mekong River Delta. And it has sort of that classic delta shape, right? That triangular shape. And here, loads of sediment are reaching the coast. A lot of sand is being dumped out here. But this delta faces the risk of collapse because of sand mining. This is a $70 billion global industry. And what happens is that sand is dredged, dug out of the bottom of the river, put onto these large barges and shipped somewhere to be used in construction in Asia and around the world. And what this means is that that sand doesn't reach the delta. So we have a loss of habitat because sand isn't making its way there to help stabilize the delta. And that has implications for the people that live on the delta too. They make their livelihood along the delta, so the stability of those habitats is important, but often their homes are on the delta as well. And so as these global deltas lose sand, people lose opportunity to live in these places, and that's exacerbated by the effects of sea level rise and potentially increased frequency and intensity of storms along the coast. But this isn't a problem somewhere far off. We see this in our own backyard too. At Virginia Beach and Sandbridge, sand is taken from offshore or out of inlets, barged or pumped onto beaches, and with bulldozers pushed around in making a beach a giant construction site. And so sand is vital for these sorts of nourishment projects, but they're also vital for natural beaches. And I'll be talking more about the natural beaches side of things, but as I move forward in the talk, I want you to think about sand as a diminishing resource. It's not renewable on human timescales. It takes millions of years for sand to be formed in mountains and tens of thousands to thousands of years to be transported down rivers to the coast and moved onto your local beach. So think about this hourglass or sand clock as I move through this talk. Sand is a diminishing resource, but an important one for our coastal communities. So that leads us to thinking about, how do we track sand? How can we track sand to aid coastal planners who need to know where sand might be in the future, as well as where sand is today? Well, when we have beautiful aerial imagery like this, nice clear water, we can see how sand moves. We can see those waves moving and breaking at the top of the picture. You can see these nice, in this case, reef islands. And we can see in these beautiful tidal inlets the channels that form as sand is moved about. How do we do that on Virginia's coast, where the geology can be a little more complex? Well, first let's get oriented. We have the Chesapeake Bay at the bottom of this picture, the Atlantic Ocean at the top. And on that Atlantic coast of Virginia's eastern shore, those beautiful green long islands are Virginia's barrier islands. And these barrier islands get their name because they act as a buffer, as a barrier to the mainland communities, to the marsh habitats that are behind the island. They act as a buffer from waves, from storms, and from the direct effects of sea level rise. And so without the sand that makes up these barrier islands, we wouldn't have them. We wouldn't have this habitat that's behind there, and the mainland communities and farms along the eastern shore would lose that protective buffer. And now we're going to focus on one specific part of the Virginia coast, Chincoteague Inlet. And this is important because there are a number of stakeholders in this area, from the town of Chincoteague itself, which is literally built on a pile of sand, an old barrier island, to Wallops Island, where NASA has a facility, as well as the state of Virginia. And then Assateague has Fish and Wildlife Service, as well as National Park Service land on it. This is 35 years of time-lapse satellite imagery, and we can see just how quickly things move around, how quickly the sand moves around in this system. We have parts that are building out. We have the inlet that wiggles around. We have sand moving from one side to the other. And this is really complex, and I'll let you sit and digest this for just a minute. But as you're looking at this, think about how can we track this sand in order to aid coastal planners? If this sand is this stabilizing force, and yet also highly dynamic, how do we track it? I'll give you a second to keep watching this video and think about how that inlet moves around and that sand builds out. One of the tools that the lab I'm in uses to track sand is a drill rig. And so this is a small drill rig on a little flat bottom boat, and we're able to take it out to these remote barrier islands along Virginia's coast. And when we get that drill rig out there, we're able to drill down about 80 feet and see all the different layers of sand and mud and reconstruct the past environments of this system. We not only can core on the islands, but also behind the islands. So this time we're not using a drill rig, we're just taking a 30-foot piece of metal pipe, vibrating it through a moon hole in the center of this boat, and we're able to reconstruct the past environment that way. And when we get those long metal tubes back into the lab, we cut them open like this, and we can see physically those layers of changing mud, changing sand. And when we get a big old pile of cores like this from multiple sites, what we can do is create 3D diagrams and maps that allow us to see where sand was in the past and where it is today. So you can see those different layers. You can see where the modern barrier islands are, where the inlets are, and where sand moves. And so we make diagrams similar to this in order to understand the past and present of sand. But how do we predict the future? We have to use computer simulations to do that. And I really like this cartoon because it says, now this is just a simulation of what the blocks will look like once they're assembled. And that's basically what we do when we simulate the movement of sand in the future, is we want to understand what it might look like based on what we know about the past and what we know about the present. And this is really important because we want to know, as hurricanes become potentially more frequent and more intense, where will that sand move? And we also want to know, as sea level rises, where will that sand go? And how can we use our understanding of where that sand might go to aid coastal managers and planners, particularly along Virginia's eastern shore? So take home this message with you today, that sand is a vital but diminishing resource, but we don't treat it like that, and we should. Thank you. I'm happy to take any questions.